Okay, so let's say you've built a great application, much like the one we're looking at right here, and you're starting to get users on the site, but some of your pages are loading slowly. What's the first thing you can do to speed up your app? Outside of solving all of your N+1 queries, of course. To speed up your app, you have to start caching things. Now, this is no surprise, it's been around forever, but what if I told you that in Rails 8, you could cache as much data as you want for as long as you want, all while saving money and removing a dependency? You'd say that sounds too good to be true, right? You'd think I'm crazy, right? Well, I'm not crazy, and you're wrong. With Solid Cache, we can do all of this and more. Now I know what you might think. I've been caching since Rails 2. What's new and exciting about Solid Cache? And you're right, caching has been around forever, but there's always been a limitation, and that limitation is RAM. RAM costs a lot of money, and many service providers charge an arm and a leg for RAM. Therefore, you can only have so much RAM to store your cache at any given time, so typically your cache will invalidate fairly quickly, and you'll have some cache misses here and there. Now, typically in this setup, the pros will definitely outweigh the cons, because you'll definitely still improve your page load times overall. But what if I told you there was a better way? You know what's a lot cheaper than RAM and has only been getting faster and faster? That's right, hard drives. And by using new NVMe drives, we can unlock a whole new strategy for dealing with cache, because with a hard drive, we can store a ton more cache compared to RAM. All right, so now let's talk about our caching solutions here, okay? So we're talking about cache, and let's say on one hand, you have a hard drive database, okay? So you can actually store your cache on the hard drive. And then let's say on the other hand, you have RAM. Let's just draw a RAM stick here. Yeah, that's pretty good, huh? All right, so now let's just walk through really quickly the pros and cons of using a new NVMe hard drive versus RAM. So typically hard drives are much cheaper than RAM. Like, I mean, a lot cheaper than RAM, which means you get a lot more storage, a lot more bang for your buck, right? Actually, let's just check out the prices really quickly here, right? So if I want 1 terabyte of RAM, how much does that cost? Oh, wow, geez. So something between like 5 or 3, 10, $5,000. Wow, that's extremely expensive. So now let's look at the cost of a terabyte of NVMe SSD. Okay, so we're talking like $60, $120, maybe $300. Now, of course, this is a contrived example. I'm not actually comparing like very granular details of this RAM versus the SSDs, but suffice to say, hard drives are much cheaper than RAM when it comes to the amount of storage you can get. Now, of course, there's a trade-off here, right? Hard drives are not that fast, but they're getting kind of fast. With the new NVMe drives, they're actually pushing some pretty good speed. Now, of course, RAM is definitely fast and is still faster than the newest NVMe hard drives, but that gap is getting smaller. But of course, on a hard drive, you can trade off this slightly slower speed for a lot more space. Whereas in RAM, you are going to be kind of limited. So what does this look like? Well, let's just go over a quick scenario here. Let's say we have a user, and this user is trying to access a page. Let's give him a smiley face. This user is trying to access a page on your website, right? For us, we've made a task page. Maybe they have a ton of tasks on one page. We have to cache all these tasks, okay? So let's say there's a page with a lot of tasks on them, and we've cached these tasks for this user. Now, if you hit the RAM cache, this comes back really fast, and it works great. But there's a problem here. Let's say that you have a ton of cache, and you have to store a lot of it. You have a lot of data that you need to store in your cache. Well, what happens here is that your RAM can only store so much. So you hit a lot of these caches, but then eventually it's going to invalidate because you just don't have the space to store all the cache all the time. So what's going to happen is you have some sort of cache misses every once in a while when this cache gets invalidated and you have to rebuild it. And typically with Rails apps on Redis, what I've seen throughout my career is you have caches somewhere in the form of hours, right? So maybe like, let's say 17 hours is kind of pushing a big cache in RAM, okay? Now on the flip side here, if this user hits our cache in a hard drive, then yeah, the initial response might not come back quite as quick as the RAM, but the trade-off here is pretty massive. In the hard drive, we have so much more space that we can store our cache for something like 60 days, which means that over the life of this user hitting this cache, they're going to have a lot more cache hits and a lot less cache misses, which means that overall, this user is actually going to see on average a much faster response time in these page loads because this cache is being hit so much more often than what we could do with RAM. So the end user is happy because ultimately they have a much faster page load time, and as developers we should be happy as well because we get to save money on our infrastructure bill because we don't need a whole lot of expensive RAM. We could just keep using more and more hard drives, and we can actually reduce our dependencies because we can get rid of Redis. Typically you would use Redis as a database store on your RAM in order to use this caching mechanism, but now since we're storing our cache on a hard drive, we can just use regular relational databases like Postgres, SQLite, or MySQL to use as a database for our cache store. So now with Solid Cache, which is the database-backed active support cache store, we can store all of our cache in these big old hard drives so we can have way more cache hits and way less cache misses. So now let's put this on our app in development so we can see how it works. Now currently this app is a beautiful task management application. We already got some seed funding, so we have a long runway. But this task management application shows a lot of tasks to a user when they get logged in. But we want these page loads to be nice and fast. So let's start caching some partials and collections for these users. Now if we go to our task index page, we can see that we render our in-progress tasks and our completed tasks. Now the very first thing we're going to want to do here to enable caching is to actually start caching things. And we do this actually pretty easily. We want to break this out a little bit and we want to call this now render partial task. We want to pass in the collection and we want to set cached, which is a boolean, to true. And we want to do this for both our in-progress tasks and our completed tasks. Okay, so this is great and all, but what the hell is this doing? Well, really quickly, this is a technique in Rails called collection caching. When Rails receives the first request to this page, it will write the contents of these partials HTML to a cache stamped with a hash. This hash being computed based on the contents of each partial. Now, if the partial HTML changes, like updating the record, the digest will change and the existing cache will expire. And by caching this whole collection versus individual partials, we can actually load all these things all at once. So the page load should be super fast if there's a lot of data in it, of course. Now, this isn't the only thing we have to do in order to enable Solid Cache, at least in development. We have to configure our database and our development environment to make sure this stuff works. So let's do that now. So let's go to our config database.yaml file. And for reference, in this project, in our gem file, you can see that we installed both Postgres and SQLite 3. And what we're going to do in this project is we're actually going to use SQLite 3 as our cache store and all of the things that we're going to store in our solid trifecta, right? That is solid cable, solid cache, and solid queue. More episodes on the other two coming up, by the way. And so what this gives us is a nice separation of our cache store and our other things that we're storing in our solid trifecta from the actual data in our database, which is going to be using Postgres. And we can see here that I've created a new anchor in this YAML file for SQLite 3. I specify the adapter and the pool and the timeout, which is very basic stuff for an SQLite 3 setup. But now what we want to do is actually configure our cache database. And what we can do here is in our development attribute, we can put a new attribute called cache. And this is going to store the relevant information for our cache database. And in here, what we want to do is inherit the things from the anchor that we created for SQLite. So it inherits all the SQLite attributes. And we're going to call this database something like solid/the life planner development cache.sqlite3. So that is going to be the folder that this actually gets stored on, if that makes sense. We'll show it off in a second. And we'll also want to store one more attribute for our migrations paths into our cache database attribute. Okay, so now that everything is set up, we should be able to actually create and migrate our cache database. So let's do that now. We can run bin rails db create. I did drop this database before just to show this off, just for reference. And we can see now that we've created our solid life planner development cache database along with the regular Postgres database that we had before. Now, if we run bin rails db migrate, it will then also migrate everything and we should be good to go. So now let's also load our fixtures so that we can test things out here. And good, we should be in good shape. Now we're not done quite yet. We actually have to change our config cache file so that in development, it's pointing to the correct database. Now under development here, we can just say database is cache, and that is the database that we defined here. It is called cache in our config database.yaml file, and the database is being pointed to cache in our config cache.yaml file. Next, we have to actually make sure that caching is enabled in development so that we can just see what's going on here. In development, in config development, we want to go down to our config cache store and change this value from memory store to solid cache store. And then finally, last but not least, we can see in a comment up here, we need to run Rails dev cache to toggle action controller caching. So down here, we can just run bin Rails dev cache to enable caching in development mode. There we go. So now let's make sure our Rails server is started, and we can go back to our application here and see that we have to log in. Now, we loaded all the fixtures for our login information. That was created in a previous episode where we went over the authentication generator. So go ahead and check that out if you're not aware of that episode. So we can log in with one@example.com, and the password is password. Don't steal that password, by the way. I'm bringing that to production. Don't tell anyone. And we just click sign in, and here we go. We see that our page has now loaded, and we see all of our tasks. But how do we know that Solid Cache is doing what it's supposed to be doing? Well, we can look at the logs. And if we look at the logs, we can see, wow, there's a lot of information here. But basically what happens here is Solid Cache is storing all of the data for these partials into the database, which is our Solid Cache SQLite database that we created. And it's inserting sort of hashed values for the data that it saw in this HTML. And so now, since our cache has been warmed up, if we go back to our logs, we should see that our cache is actually being loaded from Solid Cache, which is exactly what happens down here, which is fantastic. So now we have Solid Cache working in development. So I know this is a fairly contrived example. We're just looking at a pretty simple website in development, but I'm telling you, there's a big difference when you can cache stuff for a very long period of time. What? You don't believe me? Well, guess what? We tested it. That's right. We took this application, we deployed it to production using Kamal, which is going to be in a future video, by the way. And then what we did is actually kind of funny. We created a new rake task that made a whole bunch of just crazy data on this site. And we created a new controller called All Tasks Controller, which really just grabs every single task, which is now going to be thousands and thousands of tasks on this production server. Then what we did is we wrote a K6 script with a target duration of 2 minutes using 2 virtual users that will then hit this URL as much as it possibly can to test the load times and the response times of this page, and to simulate the difference between RAM and a database that can hold a large amount of cache for a long period of time. We changed the expiration attribute in our cache.yaml file from 10 minutes to simulate a database that can store cache for a long period of time, which in real life would be more like 60 days, versus 2 seconds to represent a Redis database that over a long period of time won't be able to store quite as much cache for quite as long as a 60-day cache in the database could be stored. So let's go ahead and run some tests right now. So in this first test, we have our expiration set to 10 minutes for the cache to expire, and we're going to run our K6 script in production, loading up all of these tasks that we pushed to this page in production. So let's run it and see what happens. Okay, so now our first test is complete, simulating a larger database that can hold cache for a longer amount of time. And we can see that our task page load time here has a P95 response of 388.3 milliseconds. Not too bad. So now let's run another test where we set our cache expiration to a smaller amount of time to better represent what could be stored in something like Redis, where the cache has to invalidate more frequently than in a large database that can hold it for like 60 days versus a few hours. Okay, now we finished our second test where the cache expiration expires much quicker. We set it to 2 seconds this time. And over a long period of time, of course, what happens is our P95 response is 894 milliseconds. That means our cache had to reload much more often. And so our average P95 response is much higher. So this shows a very big gap between a large cache hit and a small cache hit over a long period of time. Again, the previous test was about 380 milliseconds, and this one was 894 milliseconds. This really shows the power of having a large cache that lasts a long time, so that there's way more hits, way less misses. So in the end, Solid Cache gets us a lot of different things. We can now store our cache on our hard drive instead of RAM, which saves us a lot of money on our infrastructure bill. And thanks to the new NVMe drives being so fast, we don't really notice that big of a drop off in our performance. But what we get out of it is that we have a much larger cache that we can store for a much longer period of time, leading to way more cache hits and way less cache misses. And as a side little bonus, we can reduce our dependencies by getting rid of our Redis dependency. If we're not using our RAM data stores anymore, we could just use our basic databases that we're already using, like Postgres, SQLite, or MySQL. So in order to take our app from Hello World to IPO, which is the Rails 8 mantra, this offers a significant boost in developer ergonomics, a better experience, less dependencies, and just an easier way to store a ton of cache. And in the end, it's a pretty massive performance boost for end users. It's a win-win overall. Solid Cache is pretty great, and hey, Thanks, nerds.